this lesson, we are going into the exam favorite chapter about exam favorite topic bit for this chapter, which is projection at any angle. Now, you will rarely see horizontal projectile. Okay, so 6.1, that has it come up? I actually haven't seen it, but will it come up? Yes, kind of. But if they would ask about projection, then they're very likely, I would say 95% likely to be asking about projection at any angle. Then you'll be asking, if we focus so much on exam question this chapter, what about 6.4? Is it redundant? No, it's not. Okay. 6.4, in case you're wondering, is like the algebra version of what you learned in 6.3. So 6.3 is a number version. 6.4 is the algebra version. Right? So we'll have a look. 6.3, projection at any angle. So first of all, notes, the range is the horizontal distance traveled. So on the side, may I invite you to draw a little projectile. Right, so what we know is, the range is horizontal distance traveled. So basically, this is the range. The range is a distance, horizontal distance, so Sx. All right. And then at the greatest height, let's call this point G. Okay. So at the greatest height, G, what we know is the vertical component, of velocity is 0 meter per second. So what it means is at this point in particular, now vertical component velocity. So velocity could be u, y, or vy equals 0. We don't know u or v because depends if you're starting when you do a SUVA, are you starting from the highest point or are you calculating towards the highest point? If your starting point is from the angle projection, let's say in the bottom here, shooting all the way upwards, then this point will be vy because that will be the final velocity, the final position of our journey. So in terms of calculation, you must consider, when you do SUVA, you must consider which journey you are talking about in here, which part of the motion are you calculating? Are you calculating from this to this, or this to this? Let's say, let's give it a point of A. Are we talking about from A to G, or A to B, or G to B? So you must think about it very carefully, because if you're starting from G to B, great GB, okay, team GB. So G, if we start from G, that means highest point, then UY will be 0. Now remember, there's a vertical component. The UX remains the same across. Yeah, so next one, let's have a look example. So we're going to use double SUVA today, a lot of double SUVA. A particle P is projected from a point O on a horizontal plane with speed 28 meters per second. So let's draw a diagram out. So speed 28 meters per second, that means that way, 28 meters per second. Our speed is not velocity, speed. That means there's only, so the speed follows the direction of the motion. And with the angle of elevation of 30 degrees, so that's a 30 degree. After projection, the particle moves freely under gravity and it hits the plane at point A. So that's O, and that's point A. Find the greatest height about the plane reached by P. So let's call this point G. There's the greatest height. So what we want to do is, we want to find the greatest height. So when we do SUVA, we are going to consider a journey from O to G. This SUVA is for O to G. Now, why not O to A? Because we want to calculate the greatest height. If we do O to A, it mentions nothing about the greatest point. So if we want to work out greatest height, greatest point, the journey, must include the greatest height or greatest point. So double SUVA. SUVAT. First thing, acceleration. AX is always 0, as we know. Now, AY, this time, it will be negative 9.8. I'll put in here. Is negative, minus VE means negative, short form, negative because is deceleration due to gravity. Now we're decelerating, therefore negative. Okay, we're decelerating. Why is it not positive? Well, if it's positive, the particle goes up, accelerate upwards, means like a rocket shooting up and never come back down. Okay, so the fact that it's coming down because acceleration, the gravity is pulling it down. So we are shooting upwards, but we're getting slower and slower. And to that point, the speed reaches 0, then we drop back down. All right. So 0 minus 9.8, that will become the norm from now on in a projectile. All right. 0 minus 9.8, that's your first thing to do. I'll give you. So number 1 means that's the number 1 thing you always do in the projectile. Number 2 thing is the U. So UX, okay, so we have learned how to resolve the forces in previously. UX is 28 cos 30 and UY is 28 sine 30. Where did that come from? Well, if I draw this triangle out, that's my UX, that's my UY. Now you don't have to do this diagram every time, I'm just showing you. So if you use the trigonometry you see from 6.2, this is essentially what we did, right? So yeah, UX and UI, so that will become the second step. Right, now third step, okay, from third step onwards, you will have to play it by ear, depends on what you're given from the question. This time, greatest height. Read your notes again from 6.3, what do we mention about greatest height? At the greatest height, the vertical component of the velocity is 0. The vertical component, G, is the final position of a journey, so it will be Vy equals 0. So Vy equals 0. Again, you might want to put this down. Greatest height. Right. So as I said, we need 3 pieces of information to work out SUVA. We've got it. The question is, which variable do they want us to find? The greatest height above the plane reached by P. So height is about distance. Above the plane, greatest height is about the vertical. So SY. In this example, in this diagram, in the previous diagram from notes, you can do this as well if you want to. SY. So we want to find the SY. Oops. So we want to find SY. Oops. SY. So we're going to use the Y column of the SUVA on the Y column. So I'm going to rub this off on the Y column. S equals UT plus a half AT squared. Nope, that's not what I need. I need the one without T. So V squared equals U squared plus 2AS. V squared is 0. So 0 squared equals 28 sine 30. I don't know why I didn't put a calculator because that's clearly 14. Plus 2 times acceleration negative 9.8 times my S. So 0 equals, if you put that in the calculator, squared will be 196. 2 times minus 9.8 is 19.6 S. So 19.6 S equals 196. Divide that over, S will be 10, clearly. Yes, I'm right. 10 meter. Right? Part B. Find the time of flight of P. To find the time, we can either use column X or column Y, but why don't we use column Y? Because we've got so much information on column Y, so we'll continue to do that. So that's part A done. Part B. To find the time, I'll use the Y column again. This time, I might use S equals, actually, I will try to avoid S. V equals U plus AT. An exam pro tip for you. Why do I not use the formula with S, even though we got the S from part A? That's because if we got it wrong from part A, you get part B wrong. So if you can try to avoid using a previous answer, then do that. But usually, it's a luxury. You don't always have that. In mechanics especially. So in this case, we don't have to rely on the X, on the S, not X. We don't have to rely on the S, so we're not going to use S. We're going to use what we had before, V equals U plus AT. So V is 0, U is 28 sine 30, A is negative 9.8 times T. So 28 sine 30 is 14, So I'll bring the 9.8 to your left hand side. 9.8t equals 14. T equals divided over, you get 2.86 second. I write to 3SF. You should put in a calculator. You should put 14 over 9.8 in the calculator, because remember, T is a useful component in the double super because it links between the two columns. So this T value, you can either store in a calculator or use a full fraction to work out T for T, right? Because we're going to use it for C. Distance OA. Distance OA. Question number 1 for you is, can I use the same super table? Can I use the same super table? The answer is yes, but highly not recommended. So the distance OA, this super table is for O to G. If I want to find distance O to A, then I have to make a table for O to A. So I'll do that for O to A. So for part C, I need to do O to A. So I set up a new super column, super table. Oops. X, Y, S, U, V, A, T. Again, A is 0. AY is minus 9.8. UX is 28 cos 30. UY is 28 sin 30. So that's what we almost do every time. Now, next, from O to A, we need 3 pieces of information in order to work out, what do we want to find again? The distance OA. So that's the SX. So we want to find SX. But we need 3 pieces of information. We've got 2. So what do we do? Well, there's a hidden one. Now think about this. From O to A, now because they are on the same horizontal level, it means vertically you have not traveled because you've gone up and you come back down. So technically, or vertically, you have not traveled. What does that mean? That means if you go up on the plane, if you travel through a plane, you go from Heathrow Airport, one place to another, and come back down the aeroplane. That's the aeroplane. Let me draw the aeroplane. Yeah, that's the aeroplane. Yep. And then you go up, climb up the altitude, and come back down. And then on different country, technically, you can say that you have not traveled because vertically you're landing on the same position. So in other words, when the displacement, vertical displacement is 0, then the SY is 0. That's a very hidden one. So SY is 0 because O and A are on the same level. So displacement vertically is 0. If you struggle to understand about this, I'll give you one more example. Okay, imagine me, okay, going to my favorite restaurant, used to be. As I grow up, I'll try to eat less of it. McDonald's, right? So one day you can go to McDonald's, let's say that's 100 meters away. Go to McDonald's, spend 50 minutes devouring, gobbling all the burgers in there, and come back home 100 meters. Their displacement is 0 because if going right is positive, going left is negative. So 100 minus 100 is 0. So that's the same kind of concept we're talking about in here. Next, then we have our SY. We've got 3 pieces of information. Our variable is on X, but the X column we don't have enough. So guess what? We need a common thing between X and Y. That's a T. So we can work out T first. Then we can use that on the X column. So on the Y column, we'll first do that. So on the Y column, we'll do that. On the Y column, so we'll do S equals UT plus a half AT squared. S is 0. U is 28 sin 30. T is unknown. Plus a half times minus 9.8 T squared. So we can put this in a calculator. Right, if we put this in a calculator, then you get 0 equals 14t minus 9 minus actually 4.9. 14t minus 4.9t squared. This is a quadratic. When you put in a calculator, your a is negative 4.9. Okay, so or you can rearrange it if you prefer. So that will be 4.9t squared minus 14t equals 0. Put in a calculator, solve a quadratic. T equals 2.86. So once we've got that, then we can plug it into the x column. So in the x column, we now got t the value. So we can do s equals ut plus a half at squared. And s will equals u28 cos 30 times the 2.86 we've got plus half at squared, but we know a is 0, so that's gone. So if we do that, we times it by 28 cos 30. Then we got answer 69.3 meters. So essentially what we have done is double super, right? Double super all the way. So first work out a and then work out u. So a is always 0 minus 9.8, and then u is u cos theta, u sin theta for ux and uy. Then the rest of them is just playing by ear. Next example. A particle is projected from point O with speed O meter per second and an angle of elevation of theta, where tan theta equals 4/3. The point O is 42.5 meters above horizontal plane. So what's happening in here is we're going, it's a little dive from the jump board to the water. What we know is we're told this is 42.5 meters, and we're told that's traffic v meter per second, and this is the theta value. The plane strikes at the point A, so if we call that point O, this point A, 5 seconds after projectile. Okay, show that v equals 20. So from O to A, let's do that. Double see that. So first thing, A, 0, AY minus 9.8. UX is V cos, the value is, we got theta, yeah, we've got theta equals 4/3. So V cos theta and V sin theta. Next, we're told 42.5. So where's the 42.5? You can pause the video, think about where do we put the 42.5 in there? Yep, on SY, 42.5. But this will be negative 42.5. Well, why? Because if the displacement, if we start from here, we're going up is positive. Then after we come back down until the same level, this vertical displacement is 0, but then we dropped 42.5. Is that we're traveling to the basement. So it's like negative 42.5. Where we started is always think about like ground floor, that kind of sense. Anything we travel below is a basement, negative, right? So I was saying here, okay, it's negative because it's 42.5 below the projection point. All right, so it's negative. So next, we want to find V. So to find V, we need T to help us. So on the y-axis, so on the y-axis, y column. Oops, what's happening? On the y column, we can do S equals ut plus a half at squared. S is negative 42.5. U is V sin theta. Don't forget, you know the value of theta times T, which we don't know, plus a half. Actually, do we use that? Yes, we do. A half times negative 9.8 times T squared. Do that. Oh, we know T, don't we? Sorry, hang on. We know T. T is 5. I was thinking, how come we've got so many variables? T is 5. Stupid me. Pardon my stupidity. T is 5. T is 5. And also theta equals inverse 10 of 4/3. So if you plug in a calculator, inverse 10 of 4/3, that's 53.1 degree. So store in a calculator, So you do that. So you do minus 42.5 equal. Now v sine theta, if you put sine theta in the calculator, you should get 4/5. So it'll be 4/5 of v times t, which is 5, plus a half times negative 9.8 times 5 squared. We solve the equation and calculation. So minus 42.5 equals 4v minus 122.5. Bring minus 122.5 left side becomes 80. So 4v equals 80. V equals 20. Okay, positive 20. Part B. Find distance. So what's the distance? Distance is not the same as displacement. Distance is from here to here. That's the distance. To find distance, you know that's 42.5. What you need is basically the Sx in here. So from O to A, you're going to find the Sx. So there we go. We can do that. So on the X column, we'll do Suvat. S equals ut plus a half at squared. S is unknown. U is 20 cos theta, because we now know V is 20 times 5 plus a half times 0. So we don't care about the second term. We know the value of theta, so plug it in. So you got Sx equals to 60 meters. So therefore the distance is square root of 60 squared plus 42.5 squared. In case you don't know, now you know. So that's your distance. That's 42.5. What we found is 16 here. We'll find distance. So Pythagoras, you get 73.5 meters. Right, 3SF. Right? One more. The last one. Example. A particle is projected from the point O with speed 35 meters per second and an angle of elevation 30 degrees. So we'll start again. So in here, go up. And then speed is 35 meters per second, 30 degrees. It moves freely under gravity. Find the length of time for which the particle is 50 meters above O. So 50 meters above O. That's your 15 meters above O. That's your point O. Right? It would just call this line A. Okay, line A. So O to A without a doubt. Reason being is we're not given any other information. So from O to A, double Suvat. Okay, close your eyes. First thing you should do is AX, AY is minus 9.8. All right, so you should be dreaming about this, having not nightmares. No, you should be having quite happy dreams, like with unicorns of AX and AY, and then X is 35 cos 30, and UY 30 sine 35 sine 30. What a nice unicorn. Okay, fluffing about the UX and UI. Right, and then what else have we got? 15 meters. Where do you think we should put 15 in this Suvat table? There must be a place for it. Now, 50 meters, first of all, is about the vertical distance from O to A. So vertical distance, there's only one place for it. SY. All right, find time. Well, guess what? Time. So for the Y column, S equals ut plus a half at squared. So S is 15, U is 35 sine 30 times time, we don't know, plus a half times negative 9.8 t squared. Well, why is A negative again? If the particle starts by going upwards, it will always be negative. All right. Then solve the equation. You will simplify into 15 equals, actually, if you simplify it, okay, you will get 4.9 t squared minus 17.5 t plus 15 equals 0. And put in a calculator, it's quadratic, t equals 10 over 7 or 15 over 7. Now, which time do we choose then? We've got two times. Actually, none of them. What it means is when we first crosses the line A, that's t equals 10 over 7. And then when we come back down and cross the line A again, we've got t equals 15 over 7. So maybe you can tell me, how do we work at a time that is spent over the line A, which is this part here? It'll be a difference in between. So a time above O equals 15 over 7 subtract 10 over 7, which is 5 over 7. And we know no one likes fraction, like a pickle. So we make it equal decimal. Even decimal is quite ugly one. An ugly beef patty is still better than a nice gherkin. Ew. All right, so that's it that's the main thing about projectile in all direct in an angle. So what you've learned is, again, double sweep up, AX, AY, 0 minus 9.8, UX, 35 cos theta, U cos theta, UY, U sin theta. And then whatever question is given to you, other information, fit in somewhere in a sweep up table, then depends which column you've got information to work on, use that. Okay, this will be exam heavy. And that's it for 6.3.